So welcome to the next sections, and I know this is just right after maybe your lunch. So I will try to keep you all energetic, as Microsoft always supporting us as a developer with latest technologies. And now I'm going to share about serverless architecture with Azure. What you can do with serverless architecture on Azure. And before I talk about serverless, I wanted to discuss some maybe history that you might be aware of how apps have been built through years and how that lead us to the computing options we have today. So in the past, when we first have the on-premises hardware, so you have to buy your own hardware, then you might have a lot of questions showing on the screen like now. For example, like how much server you should buy and how if the server down and how you should take actions if there's overloaded with your server. So all these questions you might face before and probably now, if for those who haven't migrated to the cloud yet. So after that, we have the IaaS, which is the infrastructure as a service. So you don't have to manage the infrastructures. You just forget it. Instead of hosting it yourself, you could just utilize a server hosted by someone else. While the worries about managing physical infrastructure are gone, there are a number of questions still exist, which is about like how often should you patch your server and which OS should I use. All these questions still exist. This means that you still haven't reached the ideal state where you could focus purely on the business and its problem, where you just build your business logic, build your solutions without have to taking care about all those infrastructures, platform configurations, much on it. And then we have the platform as a service. Well, the cloud continues to help with that problem, and with the advent of PaaS, there was even more simplifications. PaaS allowed you to just worry about your apps without have to worry about your hardware infrastructures and let the cloud vendor like Azure and others vendors in the market to take care of not only the physical hardware, but also ongoing management of the operation environment like the OS operating system, virtual machines or containers, as well as the various application runtimes such as Java, .NET, Node.js, and so on. You are not completely free from thinking about servers, however, since you still have to worry about how to scale your apps. And accordingly specify the number and the various compute resources your app would need at various times. Means that you still have to worry about the compute resources, how much server do you need, the configuration still on the platform itself. I mean, you have to set up how many cores for the server you need, and how do you do the scale up, scale down, or scale out, etc. So this is come to the times where we have the serverless. Serverless is further abstract the underlying infrastructure from you. So you need to only focus on the code building, that to delight your customer with the experience, the logic to communicate with your business partner, with another platform. So serverless allow you to do just that, focus on your code and forget about infrastructure. This is why we believe it is a platform for next generations of apps. So in the coming, we will talk about roughly about serverless and the benefits of serverless, and how do we build the serverless apps, and also what are the use case and scenario that we use nowadays, and of course the concerns or considerations we have to take into account when you're building all these kind of serverless apps, which is considered quite new that many developers might not be so familiar with all this technology. So let's look at what is serverless. So abstraction of server, as I mentioned just now, is totally, you can ignore the infrastructures, can say that, while focus on building your business logic. And mostly is event-driven scale, means it depends on the event trigger, etc. And of course, it is sub-second billing. This allows you to save costs on the applications. You don't have to make your application like always on when you don't need to. So you can pay only for the amount that you use. That's what we call pay-per-use. Sub-second billing, this is how it works. Of course, we do care about your benefits. When you say about something new or something like different from the user practice, we will of course ask about what is the benefit. So firstly, as you can see, focus. So we can focus on solving the business problem in in a very fast pace, something like that, fast speed. So for example, for this MCO period, many things are just happening very suddenly that we couldn't expect, that maybe suddenly from a physical business, I have to convert myself to online business where I need to do digital marketing, where I need to do a lot of promotions and marketing via online, delivery online. So all these solutions I have to build in a very short time. So with serverless, it might help you to complete your task, or achieve your goal, the business goal, in a very short time. So you don't have to worry about much infrastructure. Like I should have to buy physical server, while many businesses are not back to their track yet. The physical business, not the online business. Efficiency. So since I mentioned, you can deploy it, deliver it very quick, right? So you have the shorter time to market as compared to the usual practice on creating a project and then or looking for machines to host, etc. So without managing the infrastructures, so you can consider the fixed cost to variable cost, because you don't have to like pay for your server for a month if you are not using it for a whole month, 24 hours, 365 days. So you can pay only on the hour basis or the second basis, depends on the services that you use on the platform. So mostly hours, so it might be also minutes. Okay, so it depends on the services that you use. Of course, it is better service stability, because the services are hosted on the platform that managed by those famous company like Microsoft and Google and all those company. So that's why anything happen to the infrastructures, you will always have the backup, have the support services providers. You don't have to worry so much. You need a team to manage all the infrastructures on that. So better development and testing management, less waste on the resources that you use to develop. Get everything on the line, onto the line. Online, because you don't have to configure hardware and all those. You just focus on development, and then you can get it up through the DevOps CI/CD. Everything is done. And then flexibility. You are easy to create a serverless applications for experiment purposes, and it fits to microservices. So whenever you want to create a new one, you can just create without much concern on the hardware itself or the platform itself already, because you just deploy the code and it simplifies the starting experience for you. Okay, after all this benefit, I think you might not be clear like how it works and what does all these benefits mean to you for now, because you never see how it works. So let me bring you through the serverless application platform component for now. This is to introduce to you like what are those components available now and you can use to build your serverless applications. Let's see what is the first one. The first one come to the screen is the functions. Functions is the place where you execute your code based on the event you specify. So you just, for functions, you just have to write really the functions, what to get from outside, process, and then you return it back. So this is functions. And usually we might call it function as a service nowadays. We call it FaaS. Basically, the ability to execute custom code on demand without have to worry like where the code is executing and how if I want to scale up if the demand goes up. This is what Azure function does for you. We'll go into detail later, but the basic thing to remember, which is it's just to execute code based on the event to specify. And next, of course, it doesn't come alone. We have the logic apps. Logic apps, I'm not sure how many of you heard about logic app before. This service was actually introduced before functions. And I want to talk about why this service is so important part of the serverless story. Imagine you are drawing a flowchart that represents a certain process in your business. For example, when a new customer record is created in a CRM system, go ahead and create a project in my project management system and then send a notification email to all these people. So we have this kind of process all the time, sometimes even more complicated than what I mentioned just now. It might involve the sales, the marketing, and what else? I mean, different of ERP systems, flow. We have, okay, so what if you could just convert all this flow, or we say flow, I mean just the flow of the business with a few clicks of your mouse into a real application that actually do those things. So you can simplify even without much coding on it. So we will look on it how it works later. But what I want to say is Azure Logic Apps effectively does that for you. Everything from starting until the beginning of a certain process. And it can be done through a visual design experience, just something like we call drag and drop. I think most of the people are familiar with this drag and drop phrase. You can create a workflow and have multiple steps, even condition in the middle, with the third party or with your own written services on Azure. And goes without saying that you don't have to worry about where all this processing happen, a server, a VM, a container, or whatever else. You focus on what you want and not like how you want to get it done. In a way, this experience is not serverless, but from a user perspective, it's often we say codeless, because this really work without much coding on it. Of course, you can custom code to make it just more advanced as you feel. Next, event grid. Event grid is a place, we call it a central place to manage all the events that can trigger a code or logic, which is the previous two that I mentioned, a function, a logic apps. So because the previous two are the event based, so you need an event to make these two work. Event grid is a place that can gather all the event in a central place and then just trigger either the function or logic app or other services else. Yes, for event grid, I will show you for how it works later, because this is just the introductions on what are the components inside. So let's see. Besides these three, right? We have already introduced the basic building block of serverless computing. So what do you want to do next? We are building application after all, and application don't exist in vacuum. They talk about database, they enable authentication for their use. So that's why we have a database in our serverless architecture here. And of course, we have the storage as a serverless service also, because you do really need to host your code, your files, your images, even you can host your static website in the storage. So as part of the services offered under the serverless idea, we have the storage. And of course, we have the Azure Active Directory, AAD, and AAD business to consumer for your security and access control needs. IoT helps to solve your IoT needs. You have the services like Event Hubs and Stream Analytics to ingest and analyze real-time streaming data. So since we are going to big data, right? So this might help you to achieve what you want with the IoT and analytics part. Lastly, we have the Microsoft Cognitive Services API, which I personally like about their services too, because for me, I don't really know how to like code the AI and machine learning things. So by having these intelligence services, I can just integrate the API with my apps, so I can enjoy like face recognitions, text-to-speech recognition, text-to-speech services, and many others intelligence services that you can think of. So all of these services together comprise the Azure Serverless Application Platform. Using this piece, you can compose your applications much better and much faster maybe. So especially in this time of period like MCO, that we are locked down, we couldn't do much of face-to-face meetings, so everything can help our business process faster. One of it is serverless. Okay, we have the platform now, but how about the process of building these applications? Don't have to worry. Visual Studio Code does. These two, they do support the serverless serverless building experience for developers. And of course, if you want to deploy it quick and fast, you can use the integrated DevOps or using the Azure DevOps or even the GitHub Actions for the CI/CD. And it supports monitoring and the debug history. If let's say there's any problem happen to your serverless apps or serverless events, you can just view it on the application inside or any other monitoring metrics on Azure platform. You don't have to worry much about like, if I just deploy my code, how about all this monitoring? Usually we have the logger to log all our informations, the debug error or the warning log, but it still can be done via the Azure platform. So let's see the first one, which is the Azure functions that personally I like it very, very, very much, since it's very convenient for the developer to achieve our goal very quickly. Azure function process the event with the serverless code where you don't have a server, not really don't have a server to get it done. Many misconceptions on this one. Server doesn't mean that there's no server at all. They still use a server to run it, but just that when you do need it, if you just put it aside, and when you need it, if you just trigger it back. So that's why we have the cold start everything that you might heard before about the serverless architecture. So these are the key highlights. Azure functions able to build, test, and debug your function code locally on your machines before the code is deployed to online. So as you can see here, composing cloud app instantly, develop functions. Okay, function is available in C#, Node.js, F#, and more code that you're familiar, not only C# itself on the Azure. So you don't have to worry that I'm from the JavaScript stack. I'm not really familiar with the C# stack, don't have to worry. We do support about it. I mean, Azure some functions do support about C# and Node.js, and you can choose what the trigger you want to get things done, and expose your functions as a HTTP API endpoint, just like what you did for the web API controller. So we can expose HTTP API with the get method, post method, delete method, put method, and it is able to scale up, scale out just based on customer demand. And you can even integrate it with other services since it's an API, right? So and you can use the NuGet libraries to do all the integration, like just what you usually write code for the web API controller. You are still able to use NuGet packages in this. So it is an event-based trigger. It could be timer-based, like 5 minutes trigger once or 5-second trigger once. It depends on your requirements. HTTP trigger or even other services trigger like the blob storage trigger, event grid trigger, and webhook trigger. Then if you go to the code, run it, process it, and then provide the output to the through the HTTP response, go to the signal R, the event grid, the database, or even the storage. So all this is achievable between the Azure functions. So then you will be curious. You might be curious about what are the trigger and the bindings available for this code, because since it's only the piece of code hosting on the platform, like how we get it connected with block storage and other services in Azure. They do have a lot of triggers and binding, as you can see here. Bindings that they have for block storage binding, event grid, event hubs, HTTP trigger binding, IoT hub binding, and all this. So whenever all this happen with changes, so it will trigger Azure function to run by getting the inputs and then return with the output. Okay, this is how the Azure function work with the triggers and bindings. As I say, it's a piece of code that you need to write, and then you can run it, you can use it. So it will be just a simple small project, as you can see here. This is one of the sample to send an email to others after getting information or data from the lead form. So on the landing page, we have a lead form. This is more specifically for marketing use case. Let's say you have a landing page submitting a form. You should need a place for the form to submit, right? So I can submit my form to this API. Built using Azure functions, and it's only one function inside here. So you don't see much like configuration and everything. Local setting, which is the local development configuration for like connection string, the storage account, you have it locally using the storage emulator, and then the dependency as usual. So inside the Mueller CS, you can see this is just a sample that returning true after the trigger through the HTTP post. As you can see here, you can define like this is for get or for post. You can have different methods for different functions, so you don't have to worry about this one. So after the passing in through the parameters, we can process it as usual inside the code here. Maybe I want to edit the data, or I want to do a condition checking, and then you can pass into the output to block and table storage as an example here. This is the output binding that we mentioned just now, as you can see here. Azure function do support all these output binding. So in this example, I'm showing you to implement the block and table output binding to store all the images or all the data that I received in the image and collect call. This is the container and the table name for these two. So the storage connection string, it will get from the local setting JSON when you're doing a local debug, or it will get from the platform when you have published it to Azure platform itself. So I remove all the code in the middle, which is quite long for this process. So in this collect formula, I actually implement SendGrid to help me send an email every time I receive the data from the landing page. So this is how I work, and it's really saves the cost since it's only paid per use, and it's like around 20 something cent US dollar for a certain number of calls. So it's not one call 20 cent US dollar, something like that. So for detailed pricing, you can just refer to the platform as I don't really remember all the pricings for all these services because it's just too low. Okay, now I'm showing you the use case for Azure Functions, which is quite convenient. The first one will be the web application backend. When you have the online order pick up from a queue, process, and resulting data installed in database, you can use this way to do. When a request is made in the web applications that you build, no matter static or dynamic web app, you can get the request to be queued in a service bus, and then when the service bus received something from the web app, then it will be able to trigger a function to process the request and then just output to Cosmos DB, table storage, and any others. Even SQL database is possible, but there's no direct binding for the SQL database for now. Next, mobile application backend. As nowadays, we're not only building web, we're also building mobile, and at a very fast process now, fast business process now. So you can make your mobile apps to call the HTTP API, which is the Azure function. This is we call the HTTP trigger from a mobile app. Then once the function receives a trigger, you can output the data in the Cosmos DB or any other database that you want. And also, not stopping here, once the Cosmos DB get the data store, it can be transferred trigger to another function. For example, after I receive this one, I want to send all this data or all this news, all these notifications I want to push to all the other users. For example, I just create a new promotion for my business. Then of course, all the users should receive the notification saying that, oh, going to have a promotion for this one. So you can simply achieve by using two Azure functions here. And of course, the mobile notification services. Okay, so this is the mobile application. Real-time file processing. Whenever you have a PDF file at a block storage, you can decompose the PDF files. No matter you want to zip it or you want to doing an OCR on it, the optical character recognitions to get all the text, to extract the text from it, to do a sentiment analysis using the machine learning. So it is possible to do with Azure functions, and it could simplify and less code on achieving these processes. So after everything done with the connected services, it can be a structured data sent to the SQL DB to store. So you can see the whole process. We don't need plenty of code on writing the machine learning and also the Azure, the functions in a big project, while you can just remain a simple code to make sure it runs to decompose your PDF and then send to OCR, finally send to the database. So this can be achieved easily with Azure functions. I think I have another two before we going after the example. Automations of scheduled tasks. For example, if your database you have for example, you are doing e-commerce, it might be creating many data. If you are doing add to cart functions. So if let's say the user don't buy it for a day, and then you might want to clean up your database, or even you clean your database for some other reasons, maybe the duplications entries. So you can use this way to constantly check on the database, which is called a timer functions. On a certain period, then you can remove the database entry based on the business logic that you want. Or maybe, for example, all this add to cart is not paid yet. After one day, I clear all the add to cart that haven't paid for yesterday. So this is possible to happen with e-commerce. And extending as application. For example, here you have Slack, or you have other communication platform that you want to extend the functionality. So you can do, or you can automate the processes with Azure function. For example, there's an issue created in GitHub, or someone do a pull request, someone just push something, or someone created a task and assigned to you. You can get a trigger to run, and then posting the issue, posting the task, posting the notifications to a Slack or to Microsoft Teams and other services platform. So after seeing all this, you might feel like, okay, it might be easy for developer to build application with this friendly platform. But how about the hosting plan and all those we can say like considerations on how to get this up on the line? I mean up online. Okay. So they offer three kind of hosting plan because it still need a place to host and run it. Of course, to save cost, by default, it is consumption plan, which is charged when a function is running, and it's also able to scale out automatically even during the period of high load. If let's say you are experiencing high load during the single days for the e-commerce, so you are able to scale out and scale up, depends on the load itself. And of course, for consumption plan, it is charging based on the function running. So it doesn't matter like how many functions you put on the platform. As long as it doesn't run, then you will not get charged for it. So you can just write as many functions as you want. You can get it hosted on Azure, and then you just pay for how many you use. That's it. This is a consumption plan. It's just that simple. And of course, there's a limitations on consumption plan. For example, like cold start, because after a certain by default it's 5 minutes, maximum is 10 minutes. After this period of time, it will go into can I say hibernations? So you need to reactivate it back when you trigger it. I mean, not manually reactivation it back. So when you call the API, it will automatically start, but it takes some time to get it back online because it will be cooled down, and we call it a cold start. So this might be a problem for you when you want to consider consumption plan, but it do able to help you save cost. If let's say cold start is not a problem for you, you don't need so many premium features, premium functionality. You can be tolerate with the cold start problems, then it's fine for you to go with the consumption plan with Azure functions. If let's say cold start you cannot tolerate, you cannot have a cold start for your API, then you can go with the premium plan, which you have the pre-warm and active instances. Then of course there's a minimum payment for the active instances that you choose. A minimum of course 1, then you have to pay. Then it will be pre-warm and always there, always online for you to execute your functions up to 60 minutes guarantee. Of course, there's unlimited execution durations, and you can flexibly choose on the instances size, how many core that you want, and also you can have a high density apps allocated for this plan. Since you already pay for active instances, right? So why not You just put multiple function apps on on a premium plan that you already pay for it. And of course, you can, if let's say you want to more secure your Azure functions, you can implement the virtual network connectivity too. And next, we have the dedicated plan, which is many people ask about, like why I should use dedicated plan, which is the app service plan, constantly paying a fixed amount while I can have consumption plan. Actually, it really depends on your business needs. And if let's say you have app service plan created before this, and it is underutilized, so you might be able to just add your Azure functions to this existing app service plan to fully utilize it without wasting the resources or paying extra money to create a new app service plan. So this is how you going to choose your plan. And for app service plan, there's one more thing, like you can consider when your function consume more than 1.5 GB of memory, or even your functions need to actively run for more than 10 minutes, maybe a long running function. I don't know what you want to do with the long running functions, but it is possible. Then you can consider app service plan. It is quite easy for you to choose between these three plans, I guess. So next we will see, okay, let's say today you have the API with Azure functions. For example, 3 API, one is for customer, one for products, one for the orders. So you might see 3 URL like this, and then you can call API whenever you want. But sometimes you might think of, since it is a separated code on separated functions app, then how if I want to have a kind of middleware or a gateway type to route all the traffic, or even I want to control the calling of each other function? There is a thing called Azure Function Proxy, which is just inside the Azure function. You can have a proxy setting there. If let's say you have 3 function app, A, B, and C, each function app have different route to different functions. So you can have API proxy here, function A as the proxy to function app B and C. So when I call the customer, you just route to function 1. But when I call the functions, the products and orders, then you go to function 2 and 3 through the proxy endpoints. So for the setting of proxy, it's just simple like this. You need a new JSON file to just map the route to the backend API to your another function 2 and function 3 API. Then it's done with this. And what can you do more about the Azure Functions Proxy, which is the serverless UI? For example, you have the SPA the single page application, you have SPA, and then for the root URL, you can just direct to the static index HTML, while for the /customer, you can just direct to function 1 to do whatever you want. And then your SPA even can call the API on function app A to execute the function 1. Azure function also can do mocking API. Can override the requests and responses, as we call mocking. So whenever it comes in /hello, as you can see here, /hello, so there's a response override back saying that hello from the body. So this is quite convenient when you want to test your API, and also you want to have a mock API to test your business logic, whether it works in your code. So that's why you don't need a dummy data or whatever things. You can just configure your Azure Function proxy to mock the API response as what you want, and then get it returning back to your code. That's it. So since Azure Functions is a stateless component, so you always think that, how if I want to have a stateful entities or stateful connections with database and any other things. So this can be done with Azure Durable Function. It's not a special things out of this scope. It's still under Azure Function, but it's just an extension to work better and work as you want. So you can have a state inside a stateless Azure Functions. So you do, whenever your VM or the process dispose or recycle, you will not lose the state of your flow, or can even remain some data in your local variable in the functions. So you can just keep it there as you want. So this is Azure Functions. So I want to show you something about the Azure function, like how does it look like in the code and also on the platform itself. So let me get my code. So this is the code that you see just now. I simplify it on the screen. So now you can see whenever I pass in, I can just process the data and then do the block storage as I want. Output to block storage, save my images, and then I can have a table storage here to store all the data with these two lines of code. And after storing, I can send an email using a send grid to the person who want to receive this kind of data. So, and then return with true and false. This is how the code looks like and the platform itself. Okay. So on the platform itself, this is the Azure Functions, where you have the function in it, and it takes some time to load. So this is the function. This is a proxy setting that I mentioned. Whenever you configure the JSONs, it will just happen here, but I don't have a proxy for now. Okay, this is the code, but you cannot see since it is compiled code here. And then you can have a monitor your console and everything inside here whenever, and you can see the URL to get the trigger. And then you have the platform feature here to configure if you let's say you want an SSL and custom domain and any other configurations here, you can just have it all in one inside the platform. Okay, next we have the Azure Logic Apps. Just now we have the code to write the whole flow, right? Make sure everything achieve what you want. And now if you want lesser code, or even you don't need a code to have a business project and workflow done, you can consider Azure Logic Apps, which is a powerful integration solutions to create all the business and processes and workflow visually. So as you can see here, we have the connectors. I mean, from top to bottom, this is the workflow. So firstly, we have the connectors to simplify the interaction with all the others system for the Azure services or the outside. So as you can see here, there are some familiar faces. For example, here this is a MailChimp, SAP, Microsoft Dynamics, Service Bus, Azure Functions. So all these you are able to find in the connectors collections for Logic Apps. So we have the trigger at the very top in the Logic Apps. As you can see here, trigger. So these are trigger. As an example, you can use the common trigger. So when an event occurs, or when a message is received in a business queue, or when a HTTP request is received. So all these you can able to do to choose in the Azure Logic app. And there's the actions building block of a Logic app, which most actions are the connectors. Flow control, you are able to achieve it in the Logic app, which you can have a if yes or no, and for each switch, terminate, and until to control the flow itself. Then you can have output back to the place that you trigger it, or output to somewhere else that you want. Okay, here I'm showing you how it looks like for Azure function for Azure Logic app. Since it doesn't have much code, so we couldn't have much setting on the code itself. Where's my screen? Okay, is it? No, not this one. Let me find the Google. Okay, for this one, yes, I have the email sending logics here to help me send an email after getting the data from HTTP request. You can see I set up the HTTP trigger, so you can try to just copy this one and then post in all these properties email from subject to which is a required field to get from the HTTP post, and then set up the send grid to send your email. While I have the test here, I try to change because I have just tested yesterday, maybe MYGAV20D2S2 as a content. So this two is the field that is dynamic content that I receive from the HTTP request, and then I will send a response back to the API call saying that email is sent to the specific email addresses. So this is the flow. This is a very basic flow that just to show you like how it works, how to send email. So if you want to add more or add a parallel actions, parallel branch, you can just add it here. So you can look for what you want: Azure Block, Outlook, SendGrid, even MailChimp is available here for the marketing one. So if let's say you don't want to just remove it. So after that, you save it. So I'm going to show you like how this works with the Postman. I'm looking for my Postman now. Okay, let's see this one. I just paste my URL here, and then I click send. So if it works, if you return me 20 okay with the email is sent to the specific email address. So now I can check my email address whether I received yes, because I clicked twice. So you can see here there are 2 emails that I received in my inbox. So this is how simple you can get things done in just like few minutes. Click, drag and drop, and then just try to include this one in your static HTML for the form sending. And then once you receive the data, you can send the email to notify certain user, not only one person. It can be many people from a list of contacts from MailChimp or from other places. So once you have the contact, you can send out and then respond back to your page saying that, oh, everything is sent. So when you click a run, basically it just runs as I post to the API. So if let's say you have any problem with the trigger, you can check it here. So it's very convenient that you don't have to worry about it. Why the calling failed, and then I don't know what happened with that. So this is how simple you can check and monitor every trigger. Okay, now back to the slide. Seems like running a bit slow. Okay, I will try myself. Logic app, here are the sample use case. One of it is recurring workflow that runs on a schedule where you can check the time, running on a specific time is a timer trigger kind of. Then you can do whatever you want, like get the travel time with traffic in a ping maps and then store the travel time. If the travel time exceeds the limit, then send an email to notify. If false, then do nothing. This is how simple you can get a workflow done in very short time. This is another sample that automates the approval workflow to get things done. For example, you have something that want your manager to approve. So you can have a send approval email. If let's say it come back with saying that, oh, I approve, the manager click approve button or send back the approve text. Then if approved, then true, add the member to list and do whatever you want, send the email on failure or success. If false, then do another things. You can even do something in the false part where you can send the email to notify your manager or the higher management saying that, oh, this one is some blacklisted customer or whatever things. So Azure function and Azure Logic App can be used together to achieve what you want. So as example here, booking applications. Users submit a new booking through the web applications. It can be queued as a message in the service bus queue, and then Logic App will listen to this one to process the incoming booking. Once there's a new queue, so it will be triggered, and then Azure functions will access the telematic information to decide whether the booking confirmations. If let's say this is confirm or reject, it will be pushed into service part topic just to publish the message. And this is only another example where you can use the computer vision services to identify on the images whether a car plate number or any human image, face recognition detection. So after we talk about all these logic and functions, is event-based. So when you have too many event triggers, it's very hard to manage in the separate places. So how if, let's say, we have all these events managed in one place? It will be very simple, right, for you. So that's why we have Azure Event Grid. So this is the place where we have the this is a place where we can discover all the events and then process all the events. Because if discovering event in your code and you need to take time to write all the logic, it might be a little bit expensive or the cumbersome to process the event. So that's why we have the event grid here. Okay, as you can see, we have the event grid here to get all the event trigger and then send to the endpoint, the serverless functions, to run whatever we want to get it done. So Azure Event Grid is a fully managed event routing. It's near real-time event to deliver at scale, and it does cover many Azure services and more than that you want. So very basic concept that you need to know is event is what happens. Then we have event publisher where it took place. Topic is where the publisher send the events, as you can see on the picture itself. And we have the event subscriptions where how you receive the event. And of course the event handler. This is all this terminology for Azure Event Grid, and later I will show how it works. We are able to manage all the event sources like show on the screen, block storage. If let's say you have something up to the block and any other events, it can be managed in the event grid and then use the event handler to process for all these events. Like for example, Azure functions to do all the process and integrate with the logic apps to complete your business workflow, etc. So even independence here, it doesn't cross over with others and is available always near real-time event, as I mentioned just now. So now I'm going to show you, due to the time constraint, I think I need to go faster a bit. So I'm going to show you the demo of the event grid. Let me see. Okay, this is the sample of the event grid viewer web app that I created just to show you like how the trigger works. So for example, I create a detect block event grid, event subscriptions. So I listen to the storage account. I subscribe to a service, the storage account. Then whenever there's a block created, I will just push to my endpoint here. You see right on the bottom. I will just push to the web app endpoint, which is a URL that you see just now, where I have an endpoint called API update. So if you just subscribe and then push to the webhook endpoint, and I'm here to show you like how it works. For example, this is the manual way I try to upload a block. For example, I upload either one of documents, okay, whatever, just this. And then when I click upload, once it finished, yes, you're able to see I have uploaded image 2020 here, and I was being notified through the event grid because I have already bind with my endpoint here. Okay, this is how it works. When you want to create, it's just simple add an event subscriptions, and you can just choose what are the topics. For example, just now what I chose is the storage account. I listen to my resource group and then my resources. What I want to subscribe, which is a block created and block deleted. So one I delete block. So if you have the trigger here too, so you can choose like what are the endpoint type. Just now I bind to the webhook. You can try to bind with Azure functions and any others endpoints that you want. So come back to here. I'm going to show you like few event grid usage. So for example, here this one, event grid to trigger a serverless function to analyze the image, to a block container. And then, okay. So these are the scenarios for serverless web applications. As you can see, for example, we have single web application here. We can call the Azure functions via the API management, and then the Azure function can connect it to Cosmos DB and to achieve what we want. And we can deploy our serverless web application through the Azure CI/CD. So this is basically the serverless web applications that we can do. Okay, and see, besides this one, we actually have the serverless bot services to connect with all those messaging services, or even you want to automate something via the cognitive services to answer the client questions via the bot services. You can even connect to API to do more functions, for example, sending mail or sending calendar invitations, many things. So in conclusion, for serverless architecture today, it is really convenient. But talking about the state, so it is stateless architecture, so you might need to have Redis, SQL, Cosmos DB, or even the durable functions to help you to do whatever you want. So just remember, serverless is very convenient, but you still need to take in consideration something like managing a state, all these concerns. So thanks for this listening to serverless architectures, and I hope you enjoy it. Thanks.